Hello all, welcome to C++ tutorials. In this video, we'll talk about setting up a C++ development environment. So it contains tools, IDEs and debugging techniques. So what is a development environment? So it is a set of tools we use to write, compile, debug and run C++ programs. So the development environment, we need text editor or IDE and a compiler, so and a debugger. These debuggers can be automatically comes with some compilers, and we can also have some other memory debuggers also. So then coming to the different IDEs that are present: Eclipse, Code Blocks, Visual Studio, Qt Creator, Visual Studio Code, Netbeans. These are all some IDEs that are present. There are other IDEs also there. Eclipse overview. So we don't need to remember everything. Just we can learn the what are the features that it supports. No need to by heart it. So Eclipse is a robust, highly customizable, integrated development environment initially created for Java. So it also supports C++ programming with help of CDT plugin. The key features are open source and cross-platform. So open source means it's free, and cross-platform, it works on different platforms like Windows, Linux, and Mac OS. So we have CDT plugin for C++, C, and it has built-in debugger. Flexible plugin system is there where we can download many plugins. Project management will be there. We can explore the projects which are present, and large projects we can manage using Eclipse. It supports makefile, CMake. So CMake will create makefiles from the projects code and then project files, and then the make will use the makefile, and then it will create the output file. So we have version control integration will be there. We can have many version control things, integration things like Git. So it will what Git does is it will fetch the code, we can pull the code, and also whatever the code we have written in the IDEs, we can push those codes. And this Eclipse is resource intensive. That means it uses more resources from the system. So Code Blocks, it is a lightweight and a beginner friendly open source integrated development environment, primarily used for C and then C++ development. It is designed with flexibility, simplicity in mind, making it ideal for students and hobbyists. So it is mainly for beginners, and it is a lightweight, fast. We can easily install it, takes less resource system usage. Is beginner friendly, easy to navigate with a minimal setup, and customizable, available on Windows, Linux and Mac OS. We have built-in GCC compiler, not modern as the other IDEs like Visual Studio Code, Qt Creator. Limited plugin support is there. No built intelligence is there. It lacks advanced code prediction. So what the code that we need to write before it won't predict that one. That kind of intelligence is not there, and smart suggestions is not there in Code Blocks. Then coming to the Microsoft Visual Studio IDE, so it has some key components like code editor, compiler, debugger, project manager, extension manager. So code editor, it also supports intelligence. This compiler will support .NET, C Sharp, VB, and then C, C++ languages also it supports. It provides debugging environment where we can put breakpoints. We can watch the code variables, and we can do step controls, moving from in and out of the functions, finding the values of variables. And it is a project manager which it contains solution explorer, organizing. It uh, manages projects, references, dependencies. It is extension manager, so it also contains Git, Docker, Azure, and more other softwares where we can install in this Microsoft Visual Studio. So it is a also we have enterprise version, we have community version for free download, supports cross platform where we can download in all the platforms, but we can write only code for developing Windows applications. Intelligence code, intelligence GUI design support is there, version control like Git, performance tools are there. Ideal for Windows application development and game development with Unity, Unreal. So some .NET, C Sharp development, embedded, and then C++ project, and then Azure connected cloud services. For these things, it is good. And coming to the Qt creator overview. So this Qt, it is mainly it supports C++ GUI development. It is a professional for GUI development. So it is advanced for the beginners. So built-in debugger is there. So first beginners has to learn many things to work with Qt. And coming to the Visual Studio Code, it is lightweight, customizable, supports C++. We need to install extensions for supporting C++, and also it supports compilers like GCC, CLang, MSVC, and debugging can be done using GDB, or also we can use LLDB for debugging. Netbeans, it is known for Java but supports C++ also. Basic debugger is there, not popular for C++, and also limited for C++. Community support is not there, it is limited. And then next thing, you can see the summary of different IDEs for C++. Code blocks, it is beginner friendly, all are beginner friendly only. And coming to the setup complexity, code blocks easy to install. Visual Studio, it takes a lot of time, and then size. Visual Studio, Eclipse, Netbeans, medium. Setup complexity. So GUI support is there. It doesn't. Code blocks doesn't support GUI support. Visual Studio heavily supports others, medium. And platform, it supports all platforms. So it is for only developing Windows applications. So for other things are for all the platforms we can develop. So code blocks, quick start with this console C++. It is Windows focused learners, professionals, Visual Studio, and then VS Code is modern, customized learning setup. Eclipse structured learning, large projects handling will be there. So Qt Creator GUI, it is for Java users switching to C++. Netbeans is useful. They can easily learn C++ using Netbeans. And then coming to the compiler. Compiler is a special program that translates code written in high-level programming language. So you can take any language, C++, Java, or Python. So that high-level language we can convert into the mission code, which is binary instructions that can be understood by machines, computer processors, and then it can execute easily. So we will pass a source code, so compiler will compile it and then produce the executable binary so that machines can execute that code. So different compilers that are present, GCC, G++, it is a GNU compiler collection, very popular, and then it is free to download. We can support, it is there in Linux platform, Windows platform, and Mac OS. In Windows we have MinGW for downloading this one, GCC, G++ in it. And Clang is there, it is fast and then modern, default on Mac OS. It also supports in all the platforms, it is there in all platforms. MSVC, Microsoft Visual C++ compiler, this compiler is only in Windows only. The Intel C++ compiler, TinyC compilers are also there. And coming to the different IDs and compilers used in Visual Studio, MSVC is there, code blocks we have GCC, and then MinGW we need to install for this one. For Linux I think we need to use GCC, native GCC. Eclipse also we need to install MinGW, and then GCC G++ we can directly we can install it. Qt Creator supports compilers like GCC, Clang, and then MSVC. Visual Studio Code, it also supports all the three, GCC, Clang, MSVC. It depends on the platform where you are working on. And this one usually Netbeans, usually GCC and then Clang only it supports. And coming to the MinGW, MinGW stands for Minimalist GNU for Windows. So it is a Windows version GCC compiler. So it supports us that we can use the GCC and then G++ on Windows, where we can run C and then C++ programs after installing this GCC and then G++ using MinGW. And it also provides GDB and then essential Unix tools for compiling code on Windows. It is lightweight and then commonly used in many editors, IDEs like code blocks, Eclipse, Dev C++, Clang, Qt Creator, Netbeans. So if you want to install in Linux, you can follow this command, open terminal, and then try to run this command. So for 64-bit version, you can use sudo apt install this -y MinGW -w64, and then you can check the version in the terminal itself if it is installed or if it is whether it is installed or not by typing this command. So it will provide this one. This information gives that it has been installed if you type this command. And then next, coming to installation, Eclipse, code blocks, Microsoft Visual Studio we will see. So first we will go to the browser. In browser, first we will download Ming. So go to the source forge, type this MinGW for Windows, then you will get source forge. Click on this one, you go to this sourceforge.net projects, it will open this one. Then you can download here. After downloading, also you try to download Visual Studio also. How to install Visual Studio, type it in Google and then click on this link, go to download Visual Studio. Here you can find the community version. We have professional enterprise versions also, but for students and then open source contributors it is free, so you can download it for free. And then also you download some other IDEs also for learning purpose. You open this codeblocks.org. In downloads, you click on this download the binary release, and then you can download. After clicking on this one, it will navigate to this page. Here you can download this Windows related release build or package for setting up the Eclipse, code blocks. And then for Eclipse, you type Eclipse IDE for C++. You can click on this one and then go to that page. Here you click on this newly available releases, then you go to this page, you will go to this page, and then you can download the Eclipse. Sorry, this is not the one. Here, this one, you can download this one, Windows x86 64. And first we need to install MinGW. Go to the downloads location where it is, where those all the softwares are downloaded. Go to the folder where this all the softwares are downloaded. Now first we will install MinGW compiler for compiling C++ code. So click on install. You need to install in a crming in C directory. You can install it here and then continue. So it will take time. Uh, After that you need to click continue, and then it will launch this MinGW installation manager. So here we have many developer tools, ADA related compiler. You can see the description here, GNU ADA language compiler and Photon compiler. Many, there are many other software tools are there. So we first install this GNU C++ compiler. This is for compiling C++ application. Mark it, and also you need to mark this for GCC installation, which includes C compiler for compiling the C code. So these two are enough for us for now. And then go to installation, apply changes. After applying, it will install the changes. So it will take time. I will let you know after completion of it. All changes were applied. Now we can close this one. And after that, if we go to command prompt, here if you type g++ minus version, you won't find anything. So to get this version, you need to add the path to bin folder. Go to this properties, and go to advanced system settings. Here environment variables, click on path, edit. Here you need to add the path. You copy the path of the Bing software installation path. The bin path we need to add. Ming folder, we need to go into the MinGW folder and then Win folder. Then we copy the path, and after that you add that path in this and click OK and click OK, and after that click OK. Then if you close the command prompt, open the command prompt again and test the version. See the version which has been installed, it will display in the command prompt. So then next we can install the IDEs which are downloaded. First you can install code blocks. Click on the software code blocks which is downloaded. Click yes. And a code blocks ID, we need to install it. Click on next, agree, next, next. So it will install the code blocks. It will take time. After completion of code blocks installation, go to desktop, run the code blocks IDE. It is still installing. So installation is completed. You can run the code blocks now. So it will open the code blocks IDE. So it opened the code blocks IDE. So after opening the code blocks IDE, go to File, New, and here you can see the project, and then select Console Application. Go next, C++. You can give the project title. And then next, then finish. It will create the project with the name my program, whatever the name you have given. You can see the main.cpp file here. You can open it, click on it, and then you can open it. So this is the data it is having, and you can click on this, right click on it, and then click on build. Then it will start building the code. You can see main.o is generated. It successfully built the application. It created myprogram.exe file. No errors, no warnings. 10 seconds it has taken, And if you want to see the output, console output, you can click on this one, run. You can see hello world here. And for testing the C++ application in Eclipse, close this one and go to the folder where the Eclipse file is downloaded. We have to extract this one. After extraction, go to the folder which is extracted, go to Eclipse. Here you can see the Eclipse. You can run it. It will load the Eclipse IDE. First time it will take a lot of time. So it will show the Eclipse workspace where we will create all the projects, CPP related projects. You can launch, click continue. It will start loading the Eclipse IDE. Close all other windows. Now you go to file. Also here also you can do same, new project, select C++ project, manage, build, next. Hello world project, click on this, MinGW, and give the project name my CPP, my CPP program, next, click next and finish it. Now you can see the my CPP program.cpp. We want to go to the project explorer, click here, select the C++ default. It will open here. You can see the project and source code. Now you can change this one, hello world. This is C++ tutorial. Save it and then right click on the project, build the project. So build finished, 0 errors, 0 warnings. Now you click on this one, so you will get a console application, local console, where it will display the output. Sorry, it will display here only. You can see hello world, this is CPP tutorial. This is how you can run your code in Eclipse, and then also you can use you can install Visual Studio. uh, Go to your downloads, so where you have downloaded, and click on this Visual Studio setup. Visual Studio installer will open. Okay, for this one you need to click continue. It will take a lot of time. I have already installed it. uh, you can directly come to that screen where it has been already installed. We will start the application from already installed one. Here you can see Visual Studio installer, uh, where you can install the different components like .NET, C Sharp, Python related. So now you can click on modify. You have to select this one, desktop development environment with C++. So you can also select other Windows UI application development. It will take lot of space, and if you click on modify, it will install it. All the software will be installed. So for now it is not required. If you modify, then it will install. You can select it. So this kind of things, it will install this many components. It will install. If you select, so it will install Windows UI application development. This is desktop development with C++ related uh, the tools, and then uh, profiling tools, debuggers, intelligence. This all things it will install. GitHub support, Copilot, and SDKs it will install. You can also see .NET environments which are required for running the applications. For C Sharp .NET, you can install whatever the .NET environment required for you, and then after completion of that, you can launch the Visual Studio. Here you can create a new project. Click on console application. Click on next, and give name for your project. create so Visual Studio installer, the project which we have created, it is loaded. You can see the solution explorer here, source files you can see it here. You can make any changes here, and what you can do, you need to build the application first, build a solution, click on here this one. Build completed. It created my CPP application.exe. You can see where it is created, and then if you click on this one, local Windows debugger, you can see the output in console application. It has shown hello world, and you can close this one. So if you want to close this project, you can go to file, close solution, so it has closed the solution which you have created. And if you want to select any another solution which you have already created, you can check here, or you can load it from open a project or solution. Now go to the PPT. So now we have installed all the IDEs, Microsoft Visual Studio, code blocks, Eclipse. If you want to install in a Linux environment, also you can follow these commands. You just open the terminal in Linux, then type this sudo apt update command, and then sudo apt install Eclipse for installing the Eclipse. You can also download from eclipse.org for this Linux environment. You can install that .deb files for Ubuntu through this terminal. So through you need to use some commands, and code blocks also you can use, you can install in this way, and then Visual Studio Code also you can install in this way. And the next one is, what is a debugger? So debugger tool that allows you to run the programs step by step, and you can pass the execution, you can inspect the variables which you have created in the program, and also during runtime you can find the bugs. Key features of debuggers: setting breakpoints, stop code at specific lines, set the breakpoints, and then step execution. We can step into, over or out of functions. Watch variables will be there. You can monitor the changes in variable values. Okay, and then memory inspection also will be there. Check data stored at memory locations. So these all things we can see. So I will explain you that. So go to this Visual Studio. Accept Visual Studio. Now let's open one project. It is having hello world. So 1 minute. I have already written one program which will print even and then odd numbers. So we can debug this one. So we will see how the debugger works. So you can put the breakpoints wherever you want. Now let's put the breakpoint at this location, 28th location, and then start debugger. Now it will start the debugging. So now it reached this location. Now if you want to execute the next this statement and move to the next line, 29th line, then what you have to do, you click on this F10, it will go to the next 29th line. The same way you can click on, it will go to the next line, but it is asking the input. You can give some 10, so it will take the input using the scene std scene input output function, and then you can enter it. And then this is a print function. What you can do then, if you want to enter into this function, what it will do, it can run that again F10, then it will come 32. It has executed all the print even function things, all the code it has executed, and I think it has produced the output for the even numbers. You can see 2, 4, 6, 8, 10, but we don't know how it has executed. So we can debug the second function. For that one, you click on this one, step into function, so that it will go to the print odd function. So it came here 16th. Now if you want to 18th line, you can click on continue. Sorry, you can click on F10, or you can click continue also, it will come at 18th line. So the next Here you can press 10 again. So here you can see the variables I and n. Now I is 1 and n is 10. So if we keep on clicking this step over, it will change. See, now I value changed to 3. The same way you can see how it will change. This is how you can see the variables, how it is affecting its data, and you can easily find out errors by debugging the code. If any issues are there, you can easily find out by debugging. And then if you want to come out of this loop, you can click this one, step out. It came out here, and then you can press this one. uh, so you can see the console output where it has printed odd numbers also. And next thing is, we have seen breakpoints, step execution, watch variables, monitoring changes in variable values, how it has modified the variables, and you can also check data stored at different locations. So what data it has stored in that variables we have seen. So the next one is this GDB debugger, where we can install that GDB debugger, and then we can debug that using bash. In bash, if you type this one gdb dot slash a dot out, any a dot out program, then what it will do, it will start gdb with executable a dot out. And so if you give break main in that bash, it sets a breakpoint at the main function, and break file number line. If you give the line of that file, then it will set a breakpoint at a specific line in the file. Runner R runs the program, next or n executes the next line the same way which we have debugged in the Visual Studio debugger. There also we have the same thing. We have seen a step or S, which will step into the function, and then continue, or C, which will continue until the next breakpoint, where we have seen that the green button in Visual Studio, and then list or L displays the source code, print value of where it will print the value of the variable in the bash. To print that variable, we can use this command, and then display where. So it will display automatically uh, the variable on each step until completion of that program, and set variable value. So it sets the value of that variable. So info locals show all local variables, info breakpoints list all the breakpoints, backtrace or bt, it removes all breakpoints, quit or q, it exits the gdb. So these are all the commands, gdb commands, which we have. And next one is valgrind. It is a memory debugger, where it will detect memory management bugs, and also it will work for profile management, profiling for the programs. It analyzes how your program uses memory even without source level debugging. The key features of valgrind are memory leak detection, shows where memory wasn't freed. So that means here, if we allocate any memory for any variable, uh, let's suppose int star ptr equal to new int. So, and then if we complete this program without passing the delete ptr, then what will happen? It is memory related issue. We are not freeing the memory. If we don't free the memory, then it will allocate memory, and then we will get this memory leakage will be there. And if memory leakage will be there, the program efficiency will be reduced. So we always have to take care of dynamically deallocate, the deallocation of the memory which is dynamically allocated using new or any other dynamic memory allocations. The next one is invalid memory access. Here also you can see this delete pointer. If we use delete ptr, then then what will happen? It will delete this created dynamically memory, and then if you try to access that same memory, uh, see out star ptr, then this is the error. So you are see it is smartly suggesting us this Visual Studio. This line is not safe as ptr is deleted before this line. It will cause undefined behavior. So this kind of things it will provide as commands. Also, it is automatically adding. So this is one kind of invalid memory access. And also, if it is out of bound, let's say suppose it stores only 4 elements, and if we try to access the let's say like a 10th element, then it is invalid memory access, where we are accessing the out of bound no, other than the array limit which we have already given, which is already fixed to only 4. This is also one kind of error. And then we have segment fault, where we don't have access to that particular memory. That also causes invalid memory access. We should have permissions to access some particular memory. And we have uninitialized memory use alerts if we use memory before assigning a value. So this one is uh, what we will allocate. uh, we will create one variable like index, and we are not initializing this variable. We just declared it, and we try to access it. Suppose int y equal to x plus 1. So this is also accessing the variable which is not initialized. It is telling the it will give potential error. So should not use uninitialized memory. This will also the valgrind will automatically detect. And thread debugging will be there. Tools for detecting race conditions. So threads, what it will do? Threads can execute simultaneously. It can run two different parts of same program. It can run one thread can run this one, another thread can run this function. The same way, threads also can access same function. And if we have any variable here, uh, that variable updation, if we are doing anything, uh, x equal to some value, some y, then because of some issues, what will happen? This shared variable causes race conditions, where we are not using proper synchronization mechanisms here. So due to that, the program may crash, and undefined behavior will be there. So this data for this variable will be uncertain. So those kind of issues we will get it. And then the next one is the check the profile performance profiling. So what it will do, it will tell us the program where it is inefficiently working. Means uh, uh, where exactly the program is executing, taking more time, and where exactly which function call it is calling many times. So those all things it will detect, and the frequency of function call, and then timing it will give us, so that we can avoid it, we can reduce, uh, we can make efficiently the code. And some common tools inside valgrind are memcheck for memory error detection. So different features we have for GDB, LLDB, valgrind, these two, and then valgrind. We will see the differences. So type this GDB and then LLDB are debuggers. This is memory debugger and also propeller, where we have already explained this propeller and then memory debug things and debugger things. And primary use debugging C++ application. This is also same. This is detect memory leaks, errors, and profiling. Platform, it is Linux, Windows, Mac OS, Linux, Mac OS. Performance moderate, faster. It is slower because it simulates the program. Multi-threading supports, good support. It is excellent support is there. It is also supporting, and then also it is providing rest conditions, detecting rest conditions and thread errors, and integration. So it is there in GNU toolchain, widely used with GNU toolchain. This is used with CLang and LLVM, and it is valgrind is mainly used in CI/CD pipelines, continuous integration, and then continuous deployment to the production environment. The code whatever we have written there, we can use this valgrind, and catches runtime and then logical errors, be divided by zero, and then some memory related errors which we have seen, logical errors where the programmer not properly written the code, some different code has written those things, catching. And then it LLDB also same as this GDB. So it provides memory leaks, invalid access, uninitialized use, which we already explained. Okay, that's all. Thanks.